So now we're going to simplify some expressions using properties of fractional exponents. So let's work on this problem 3a. We have one parenthesis multiplied by another, and frankly speaking we don't need parentheses because we have all the terms multiplied together. So we can rearrange the terms in the way that is beneficial to us. So we get 3 times 4 times x to the 2/3 times x to the 3/4. So that is 12 times x to the power sum of those exponents, 2/3 plus 3/4. So I would like to figure out how much is 2/3 plus 3/4. So we turn those into 12s and we get 17/12. So this is the same as 12 times x to the power 17/12. What does it mean in terms of radicals, in case you really need to calculate it? This over 12 becomes the 12-degree root, and you have x to the power 17 inside of that 12-degree root. But preferred way is just the fractional exponent. So here is another problem. We have 72x to the power 3/4 over 9x to the power 1/3. So we obviously can cancel 72 and 9, so there is 8 in numerator. And we have x to the power 3/4 over x to the power 1/3, so it's gonna be x to the power 3/4 minus 1/3. And so that's what is written there, 8 times x to the power 3/4 minus 1/3. So we just need to figure out the difference of 3/4 and 1/3, and again, doing some fraction calculation, we get 5/12. So this is 8 times x to the power 5/12, and using radicals, which could be helpful but not necessary, this is 8 times the 12th root of x to the 5th. Okay, let's look on this problem D. This is 4th root of x to the power 24. So it's beneficial to write it as x to the power 24/4. That's another way to write that same exponent. And then we can reduce 24 over 4 into 6, and that's x to the power 6. That's the easy way to simplify this. Now let's look on problem in part C. We have 125 x to the 9th times y to the 6th, all of that to 1/3 power. So what we'll do, we'll distribute this 1/3 power over the 3 terms you have in the parentheses. So we're looking on 125 to 1/3, x to the 9th to 1/3, y to the 6th to 1/3 power. So then we're going to take different approaches to different terms. So this 1/3 exponent of 125 is third root of 125. And for x to the 9th, then to 1/3 power, we'll take the power of the power rule. So that will be x to the power 9 times 1/3, which is exactly 9/3. Likewise, y to the 6th and then to 1/3 is y to the power 6 times 1/3, which is 6/3. So cube root of 125 works out to be 5. And then 9/3 is reduced to 3. 6/3 is reduced to 2. So that's all we have here. 5 times x cubed y squared. Then in part E we have 12th root of x to the 4th y to the 16th. So I can do that as 1/12 exponent of x to the 4th y to the 16th. And then we're going to distribute it over the 2 terms we have in the parentheses. So it's x to the 4th to 1/12, y to the 16th to 1/12 power. Or by the power of the power rule, you do 4 times 1/12 and 16 times 1/12. That's x to 4/12, y to 16/12. So after reduction, this is x to 1/3 times y to the power 4/3. Because we can reduce each fraction by 4. Then in part F, we have 2 parentheses raised to different exponents. So we're going to start doing similar things. So in the first parenthesis, we're going to distribute 1/3 exponent over the 3 terms. And we're going to distribute the 6th exponent over the 2 terms in the second parenthesis. So we're going to have 8 to 1/3, x to the negative 6 to 1/3, y cubed to 1/3, x to the 5/6 to the 6a, and y to the negative 1/3 to the 6th power. So then by the different rules, 8 to 1/3 power will be cube root of 8. And the rest of the terms are simplified by the power of the power rule. So multiply negative 6 by 1/3, get negative 6/3. Get y cubed to 1/3, get y to the power 3/3. X to the power 5/6 to the 6 will get x to the power 5 times 6 over 6. And y to the negative 1/3 to the 6th power will get y to the negative 6/3. After that, we reduce all the exponents as much as we can. Cube root of 8 is 2, negative 6/3 is negative 2, 3/3 is positive 1. This whole thing, well, 6 could be cancelled out, and you get exactly 5. Negative 6/3 is negative 2. So then we can combine x terms together. X to negative 2 times x to the 5th will give us x cubed. Or, so before doing that, we can rewrite the terms so that we have x terms together and y terms together. So we get x to the power of 5 minus 2, which is 3, and x to the power, this is a y to the first power. So I get y to the power 1 minus 2, so that's y to the negative first power. And then this y to the negative first should go into denominator. So the final answer is 2x cubed over y. We're asked to simplify the expression, and we need to simplify it as much as possible. So this is the copy of that expression, 5th root of 32h to negative 7 s to the 4th power over 5th root of h to negative 4th s to negative 2nd power. So I'm going to go ahead and split the numerator. There is 5th root of 32 times 5th root of the other two variables. The reason for doing that is that 5th root of 32 is actually equal to 2. And that's what we're going to get on the next version of this expression. And then 5th root is the same as 1/5 exponent, so we're going to use that, and we're going to distribute 1/5 exponent on each term. Get 1/5 exponent of h to the negative 7, of s to the 4th, of h to the negative 4th, of s to negative 2nd. So then by the power of the power rule, we get 2h to negative 7/5, s to the 4/5, h to negative 4/5, and s to negative 2/5. After that, all the terms with negative exponents should go in the opposite places. So this h to negative 7/5 in numerator should go into denominator. And that will cancel this negative exponent. And then these two terms with negative exponents. So let me do them separately. So this term, h to negative 4/5, should go upstairs, and that will cancel that negative exponent. And s to negative 2/5 should go upstairs as well, and that will cancel the negative exponent. So in the end result, so 2s to 4/5 stays the same. Then h to positive 7/5 is in denominator, and h to 4/5 and s to the power 2/5 happen to be in numerator. So now we can combine and simplify things. We have two s terms, s to 4/5, s to 2/5. That should give us s to the power 4/5 plus 2/5. And then we have h to the power 4/5 upstairs and h to the power 7/5 downstairs. So when we cancel things, we have h to the power 7/5 minus 4/5. And I'm going to keep it in numerator because numerator exponent is larger than the, well, should have said I'm going to keep it in denominator because the h in denominator has the largest exponent. So once we do the arithmetics with fractions, we get 2s to the power 6/5 upstairs and h to the power 3/5 in denominator. So for the answers, we're going to put numerator being equal to 2 times s to the power 6/5. That's how you would put it. And denominator is h to the power 3/5. That's again how you would put it online.